Okay, this is section 6.6, properties of logarithms, page 416, Algebra 2. We're going to talk about three properties. The book breaks them up, takes one at a time. I'm going to throw them at you all at once, okay? We have the product property. Of logarithms, so I'll just say of logs, okay? And it says that if I have the log of some product, we'll call it AB, base x. So I'm taking two things times each other, you see that? Base x. That this has exactly the same value as the log of A base x plus the log of B base x. Okay, so you can split them up. If there is a product rule, guess what? There is a quotient rule also. Now I'm going to go through these and show you examples. There's a quotient rule property of logs also. And it says the same thing.
Interruption. Excuse the interruption, but please do not print down to the computer lab printers. Thank you.
Okay, if we're dividing A over B base x, that this is the log of A base x, and we subtract the log of B base x. So the one in the numerator is subtracting the one in the denominator. Okay? And then the last one is called, I think this book calls it the power property of logs. The power property of logs. Okay. It says if we have log of some number, we'll call m base x to the p power, that we bring the, see it's some number to the p power, we can bring the p out front and have the log of n, so p times the log of n base x. And these three properties we're going to talk about today. And they all work, all right? Okay, I'm going to show you one that's pretty tough, because you have one that's pretty tough on your assignment. I'll try to show it to you also. But we're just going to do some examples. I'm going to go from this examples to your problems and things like that. But we're going to say, it says use the log of 3 base 4 is approximately, this wavy equal sign means approximately 0.7925. And the first one we're going to do is, number 1, the log of 192 base 4. Okay. So what we want to do is we want to try to find out what the log of 192 base 4 is based on this information right here. So we got to use a 3. Okay. One thing I want to tell you, whenever you have a log to a base, right, in this case we have base 4, that we also know this, that the log of 4 base 4 equals 1. So we also know that, because the base is 4. So if this base went to 5, I would know the log of 5 base 5 is 1. You see what I'm saying? So whatever base we are, we do know that one also. I'm gonna give this one to you. This can be written as the log base 4 of 4 to the 3rd power times 3. Now most of them you won't be that tough. This one's a tough one because you got to figure out the factors of 192 using 3 and 4, right? I'm going to show you one from the book that's pretty tough too, but I have to use those factors, all right? Does everybody see where I got these? Okay.
What does it say again? It's a log of base 4 times.
This the log of 4 to the 3rd power times 3.
Okay.
okay? Okay, what I want to share with you is 4 to what power is 4 to the third?
The negative 60.
Well, if I go up here, back up here, if I go log of 4 squared base 4, what's the answer to that?
2.
It's 2. 4 to the second power is 4 to the second power, isn't it?
Oh, yeah.
So if I go log of 4 to the third power base 4, that is what? 3. 4 to the third power is 4 to the third power, right? So if you have this number and this number the same, whatever exponent it is, that's what it is. So log of this, so I can break this up using the product property. I can say the log of 4 to the third base 4 plus the log of 3 base 4. Using, what I did was I used this property right here. Correct? So that means this is 1, this is 3. Where did that come from? This concept right here. CJ, you following that?
Yep.
Plus, and then I know, they told me in the directions that this was equal to 0.7925, right? So my answer is approximately equal to 3.7925. Okay? Any questions on that? All right, let's take this. It says number 2. Use the log of 2 base 4, we got still base 4, is equal to 0.5 to find number 2. Oops, this is directions, this is number 2. The log of 32 base 4. So I want to use 2 and 4 if I can to get 32. Okay? Well, okay, all right. Did you hear her? She said if you take 4 squared base 4, 4 squared times 2, you'll get 32. Is that correct?
Yeah.
So now I can take the log, since it's multiplied, I can take 4 to the second power base 4 plus the log of 2 base 4 using this rule again. Well, since this is 4 and this is 4, that is 2, right? 4 to the second power is 4 to the second power plus 0.5, which is 2.5.
Which shows, where did the log 2 base 4 come in at?
Right here?
No, the next, the one over.
Right here?
Yeah.
Okay, so this is the log of, you get this, 4 squared times 2 is 32, right? 16 times 2 is 32, correct?
Yep.
According to the product property of logs, if I'm multiplying the two, I can split them up and add them, right? So I can add the log of 4 squared base 4 plus the log of 2 squared base 4. If I'm multiplying, this is A and B. A is 4 squared, B is 2.
Okay.
Does that make sense?
Yep.
Okay. All right. Questions? All right. Let's try another one. Given the log of 5 base 2 is approximately equal to 2.3219. And I want to find the log of 25 base 2. Okay? Alright, so I wanna use either log of 2 base 2 or log of 5 base 2, because those are the ones I know, correct? Correct?
Yes.
So, I don't know if you know this or not, you do, but 5 squared is 25, correct? Alright, now I'm gonna show you the property rule, or the power rule, excuse me, the power right here, right? It says if I have a exponent, I just move it to the front. So I take this 2 and I move it to the front. The log of 5 base 2. Do you all see that? So I move the 2 in the front and I take the log of 5 base 2. CJ?
Yep.
So now I have 2 times the log of 5 base 2. I know the log of 5 base 2 is this, so I have 2 times 2.3219. So what is 2 times 2.3219? If you multiply those together on your calculator, you get 4.6438 to 4 decimals, correct? Any questions? Okay. Alright, I'm going to look at your exercises for just a moment and then come back. Okay, I'm going to look at 23 through 26. I'm going to look at number 26. It's in your assignment. The directions say solve each equation, check your solutions. Hopefully I have enough room here. 26 says the log of a base 10 plus the log of a plus 21 base 10 equals 2. Harper, the first thing I need to notice is that both of them have a base 10. If they don't have both the same base, you're in trouble. Can't do anything. Can't apply either one of these properties. Okay? The next thing I'm going to notice is that we're adding them, right? Well, in these 3 problems, I went from here to here, correct? Now we're going to go from here to here. This is what we call expanded form. This is condensed form. How do I go from here to here? Well, A is A in this case, and B is A plus 21, right? So what I'm going to do is I'm going to put them back together. I'm going to say the log of A times A plus 21 base 10 equals 2. You see how I put them back? I went from here to here, correct? I went from here to here, not from here to here. I put them back together. All right, this is called logarithmic form. Can anybody write this in exponential form? Remember the first section?
20 log.
You can't have a log in it if it's an exponential form.
Um,
My base is 10, right?
Oh, A times A plus 21, the 2 power equals 10.
How about 10 to the second power? This is the base, this is the exponent, this is the answer. Base, exponent, answer. Now I just solve. We got rid of the logarithms, right, Carly? So I can just say a squared plus 21a equals 100. If I square that and I put it all on one side, it's a quadratic equation. And I factor that. I want factors of 100 that add up. What's that? Factors of 100 that add up to 21. A plus 25, A minus 4, correct? Equals 0. Do you remember how to factor that? We're reversing FOIL. We're reversing FOIL. What's wrong? Dawson, I reverse FOIL. A plus 25 times quantity A minus 4. I'm sorry. I'm getting down here. I'm getting nervous about getting down to the bottom. So my 2 possible answers are what?
25 and maybe 4.
Actually, it's a negative 25 or 4, correct? Now I'm going to tell you something. One of these answers does not work. Negative 25. You want to tell me why?
Negative.
It's negative, and you can't take the log. You can't take 10 to any power and get a negative. 10 to any power. So we throw this one out. My answer is 4. Okay? All right. Let's take a look at page 420, numbers 28. It says, use the log of 3 base 5 is approximately equal to 0.6826, and the log of 4 base 5, they gotta have the same base, don't they? Is equal to 0.8614, is that right? And we gotta find each, and number 28 says the log of 40 base 5. Now I wanna do this one because this one actually, since it's the first problem in the section, you think it's the easiest, but it's actually one of the more complicated ones. So what I wanna do is, I know these things. I know that log of 3 base 5 is this, I know log of 5 base, or log of 4 base 5 is this, but I also know that the log of 5 base 5 equals 1, right? And then I can change this to 5 squared, 5 cubed, so forth. Oh, excuse me. All right, any questions so far? So what I have to do is use 3, 4, and 5 to find 40. Okay? Well, the only one I could think of was
5 times 8.
5 times 8. That's exactly what I came up with. Right? Base 5. 5 times 8. You agree 5 times 8 is 40? Okay. So using the product rule, stay with me, log of 5 base 5 times the log of 8 base 5, correct? Are you with me? Okay. You guys should know what the log of 5 base 5 is. 1. Oh, this is supposed to be a plus, sorry. But this is the tough one, Jaws. So I'm going to tell you what it is. 8 can be written as a power of 4. I don't know if you can know this, but 8 is 2 to the 3rd power, correct? 4 is 2 to the 2nd power, right? Well, we can use this concept. We can say that if I take 4 and I take the square root of it, right? Correct? That's 2, right? And then I can cube it, right? Is that true? That is really 4 to the 3/2 power. Okay? And let me explain that to you. There's a rule that we learned, and I don't know if we learned it, if we can remember it. But if I take a to the m power to the nth power, or to the nth cube, excuse me, that this is a to the m over n, that the root is the denominator and this is the numerator, and that's exactly what I've done here. Okay? So I can replace 8 with 4 to the 3/2 power, base 5. And then I can use the power rule to bring the 3/2 back in front and take it times the log of 4 base 5. Correct? And that's, I know that's weird, but now I have 1 plus 3/2 is 1.5 times and I know that the log of 4 base 5 is 0.8614. So if you'll plug that into your calculator, please.
Wait, 0.
1 plus 1.5 times 0.865. They'll do this first. Your calculator will do that. Tell me what it is the 4 decimal places.
1.2921.
Did you add 1?
Not yet.
Okay, add 1. Just add 1 to it. 2.2921. Okay? Now, is 29 that hard?
No.
No. Well, actually 29 is pretty tough. Okay? But 30, you just take, let's take a look at 30. You have the log of 3/4 base what? 5. That one's pretty straightforward, guys, and here's why. This is the log of 3 base 5, since we're dividing, right? We're going to use the quotient rule. So what goes in here? Minus the log of 4 base 5. And all you got to do is plug in. So that one's pretty easy, right? Questions? Yes, you have a question, Uton? I'm going to plug log of 3, I'm going to plug this in here. I'm going to plug this in here and subtract the 2 using my calculator. Right? Okay. One more, and then we're done. Let's take a look at 41. Stay with me here. 41 is, it says, solve each equation, check your solution. Watch for negatives, okay? So we have 3 log of 8 base 10 minus 1/2 of log 36 base 10 equals the log of x base 10. Correct? You okay, Hart?
Yeah.
You good?
I'm looking.
Okay, sorry, I'm trying to write it as best. This log stuff is pretty tough.
No, it's just the glare from
All right. So this is expanded form. I want to condense it. I want to put it back to one single log. Do you understand that? So the first thing, I'm going to reverse the power rule. So I'm going to go log of 8 to the 3rd power base 10. Notice how I took the 3 that was out in front and I put it back up top here. I'm going to do the same with this. Minus the log of 36 to the 1/2 power base 10 equals the log of x base 10. Is that correct?
Is that log 8 to the 3rd?
Yes. Does that make sense? I took the 3 from out the front, really, and I put it up top, right? I reversed the power rule is what I'm saying, correct? So now I'm subtracting, right? Which means I'm doing what? If I put them together, I'm doing what?
Dividing.
I'm dividing. So I have the log of 8 to the 3rd over 36 to the 1/2 power, right? Base 10. Can you tell me what 8 to the 3rd power is?
512.
It's 512. So I have the log of 512
Over
over, what's 36 to the 1/2 power?
6.
It's 6. Explain that to me.
It's 36 squared.
Okay, it's the square root of 36, right? All right, now take a look here. I have 2 logs that are equal, correct? They have the same base, correct? If you have that, there's a rule that says the log of m, if the log of m base b equals the log of n base b, then m must equal n. That's what I got here,
So
guys.
X equals 512.
That's right. I get 512 over 6 must equal x because the logs are the same and they have the same base. So x equals 516 divided by, or 512 divided by 6, which I believe is like
85.33.
85 1/3. Okay? Do you understand? So we've actually used all of the rules there, except for we did not use addition, but it was pretty close. Okay? All right. Your assignment for Monday, and this will be the first assignment on the next 9 weeks. Page 419, 23 through 26, comma, 28 through 45. I will give you tomorrow to work on it, and also Wednesday. Wednesday's a shortened period. Okay?
240, right?
Page, what?
It's 240.
Yes, 240 on Wednesday. Yep.